Testing, testing. Testing, testing. Okay, now we've got our build function. Let's see. We've got our updater and our updater thing that produces a list of updaters. And the first thing we're going to do is change the name of it. I think builder is a much better name for the interface. So let's go back to our interface. So we got updatable base and updater. First, let's just change the name. So F2, F2 not working. Refactor, no refactoring is available. So we're gonna have to do that by hand. Builder base. I'm not sure what's going on there. And then, so this is going to be builder base, and this is going to be okay. We got to do everything manually. So we'll say builders. We'll call it builders, or builders executor. I just call it builders. Nope, not builder base. Builders, just like I spelled it, just like that. And then we'll call this extends builder base. And this will be builder base. And this too will be builder base. And now we'll change this to builders. This is the one that executes the list of builders that we drag into there. And the function, we want to rename the function to build. The main thing is we can't call it update because that's the frame update. That method's already taken, so we don't want to make things confusing. Builder, or build, so that's the name of the function we want to use. And that means that builders, since it implements it, is going to have, it overrides build. And the first thing we want actually is something that will delete children. Delete all the children of, so that like when we build, it'll be a rebuild. So our first builder will be something that deletes things. And so, oh, yeah, that's where we want it. Back to here. Oh, give me my thing back. That's where we want it. Right there. We'll just call it destroy children dot children.cs, and using Unity Engine and namespace DLN, public class destroy children extends, what do we call it, builder base. And all we need is, I would say, let's keep it simple for now. So public override void build, and then the build method would say destroy immediate. We want to destroy immediate because it's in the editor, so if you just say destroy, it's not necessarily going to work in the editor. And what we actually want here is all children. So for each var child in this dot transform destroy immediate child dot game object. So I want to do that before I forgot, and we're going to have to manually format things here, which is fine. And then now we're going to make a spawner. So we want spawner.cs using Unity engine and using, we got Unity engine there, namespace DLN, public class spawner extends builder base, and then public override void build. And hey, let's make sure we did an override. Yeah, we did override for that one. Okay, so this should take a list of prefabs. So serialize field private list of game objects prefabs equals new list of game objects. And so that's a list of type game object. That means it's a generic list. It's using generics. So we need using system.collections.generic. And from there, let's say number of instances. So we would say serialize field private integer num instances equals 1 by default. And for our build, let's say for int I equals 0, I is less than num instances I plus. There we go. And from there we would say for each var prefab in prefabs. I think I'm doing this for my health now. Okay. And we would instantiate that prefab under this transform. So this transform is going to be the parent. This dot transform. And from here, oh, that should do it. So we have a repeat right there. Okay. And then from there, so we have build and destroy. that should be enough to test it. Let's make sure. Let's look it over. Alright, so let's go back to the editor and refresh. I almost want to use paint here. Object does not contain a definition for game object and no accessible extension game object, no accessible extension method game object, accepting a first argument of type object. So let's go back to there. That is in our spawner. Oh, no, that's in our destroy children. So for each var child and this dot transform, for one thing, let's try to just transform and see if that works. That's very strange. Did it pull in a different namespace? It did not. Using system.collections and using system.collections.generic. I don't think that's going to fix it, but I think maybe if we specify exactly what type it is, that might work. I don't think it's properly inferring the type. So we're going to say transform. So for each transform child in this transform. Let's see if it did it better now. Refresh. This is what it's like to code. Builder base does not contain a definition for update and no accessible extension. That is in layout builders 1628. So I guess we fixed that one. That's what it was. It's unable to infer it. And then builder base build updatable dot build. And then let's just rename these two. See if we still don't have refactor. For each var builder, and we'll call this buildables. Buildables. Call it builder. Gotta be lowercase because it's the name of our class too. Buildables dot build. So we got builder, buildables dot build. That should do that. Builder base does not contain a definition for build and no accessible extension. Really? But I know that it does. Buildables.build. And then we go to builder base. Right there we have build. So let's try building it, like compiling it again. Maybe it missed it. Oh, okay. So it was a list. So I'm calling it on a list. We have a list of builder base, which is a list of. Okay, so we got that. which file was this on? This is on file builders. So builders. So that's one thing. Builders. But I do not see us calling it on a list. No, it's not calling it on a list, so maybe it just got confused there. We will see in just a second. I'm spelling this right. B-U-I-L-D. B-U-I-L-D. Build and build. Okay. Refresh. So list builder base does not contain a definition for build and no accessible extension method build accepting a first argument of type list of builder base could be found. Are you missing a using directive or an assembly reference? So it thinks that I'm calling build on a list. That's in line 16 of builders. So let's go to builders. 16. Because I said buildables.build. That makes sense. Builder.build. These are things your editor would normally catch, and ours is not working, and I'm not messing with it. So we're going to learn how to, I'm going to get me some practice not using any help. So no AI, no help from the IDE. I've set up the IDE. IDE is like, probably more than 100 times. So I'm tired of it. Alright, so we got that. Let's go to, we gotta test our prefab. So we're going to remove these because we changed the name. So, and then remove component, then add. So we want builders and add component, spawner, and we want a list of spawnables. So let's go to, we're just going to pull out some random stuff. So let's go to our main scene. Yeah, we'll go ahead and save. And in our main scene, we're just going to produce a few like primitive types. So let's do an arch, and what else can we make? Pro builder, cone, and pro builder cube. And we'll make those into prefabs just by dragging each one. So cube, cone, and arch. And now let's delete those from the main scene. Delete it. And our spawner is going to spawn arch, cone, and cube. And let's make sure that works. So here we have our update method, and see, it's still called update because the way we set it up, we have builders We call it context menu update. We'll change it to build, but we're not going to compile it because it's not really, we're not going to compile it just yet. It'll show up on our next iteration. But we're going to call that function and see what we got. We're trying to save a prefab with missing script. This is not allowed. Alright, let's go back to our updater test. So, I think we had the beat in the prefab. And let's update. Prefab with a missing script. It's clear. And we're going to go... Oh, right. We have to add that to our list of builders. So our spawner will be the first one in the list. Right. And then let's go build. Updater test. Let's make sure they were added. Arch, cone, cube, in the order we put it there. Now let's say we had 2 instances. Let's delete those. And build. Oh, update. Arch, cone, cube. So arch, cone, cube, arch, cone, cube. And right now they just overlap each other. So if we go like this, we go like this, you can see they are... Oh, interesting. This gave us... Oh, there's a bunch of them, right? So let's just make sure though. Let's delete 3 of them. Yeah, obviously we have arch, a cone, and a cube. And we'll go ahead and delete those again. So now what we want to do is, before we spawn, we want to delete everything that's there, right? So we would have our destroy children builder. A destroy builder. Destroy children. And just to, so we have it in order. It doesn't have to be like that in order, but on here it will need to be in order. So first we could just drag it there. Actually, yeah, we could just drag it like this. So we're going from here to here. And now if we build it twice, so update, and if we update again, it should replace them. Arch, cone, arch, cube, arch, cone, cube, arch, cone, cube. So did it delete all of them? 1, 2, 3, 4, 5, 6, 7, 8, and 9. That's odd. Let's see what happens when we do it again. So it should destroy immediate. So we got the first updater destroys children, and then spawner. So that should work. What do we got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It seems like it adds an extra arch each time. Let's try it one more time. So this time, if the pattern follows, we'll have 11. So now we have 11 of them. So what's going on there? Destroy children. We got for each transform child in transform, destroy immediate child.gameObject. That's correct. And then in our spawner, We have I equals 0, I is less than number of instances, I plus plus, that's correct. For each prefab and prefabs, instantiate the prefab into this dot transform. That's interesting. Maybe it's another one of those like Canton for the type. I don't think so. Prefab and prefab. This is editor code, so that could be why. And then it was added to this dot transform. Let's say transform, maybe that works. How it's getting confused and adding 1 is beyond me right now. Let's go back to here, refresh. Let me pull up Paint. Oh, it's still compiling. Let's do some drawing. The next thing we're going to do is create like row spacing. So, but first we have to get this to work, and it's a very strange bug. We should only have 9, and it should delete all children no matter what. So, if we go to here and we press build, we should not have 9 for one thing, we should have 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. But we have 11. And then let's see if we delete them all manually, what we have. Go back to here and build. So we have 6. 1, 2, 3, 4, 5, 6. So if it doesn't delete them, we should have 12. If it deletes them, we should only have 6. That's the behavior that we're looking for. And when we press build, we have, instead of 6, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Oh, we've got some errors. Hold on. Let's see if that comes up again. So when we go like this, oh, back to here, build, no errors. Try building again. And then build. It adds an extra, but not. There's not even 12 there. Why is that? I think it needs to be like, update needs to be called or something. This is a very strange error. Because the code is very clear cut here. Destroy immediate child.gameObject. The only thing I can think is, since it's a for each, we might not be able to do that. So sometimes for int I equals 0, sometimes in a for each you can't modify it. I is less than transform dot count, and I plus plus, and we would say destroy immediate transform at I. I don't even know if it's I don't know if I enumerable is necessarily indexable. Let's go back to our right, refresh. Transform does not contain, it doesn't contain a definition for count and cannot apply indexing to an expression of type transform. Okay. What's another option here? That's not going to work. If we can't do it that way, can't index them. I'm going to ask ChatGPT on this one because that's very strange. What's the proper way to destroy all children under a transform and Unity editor code? So this time we're getting help this time. Usual pattern: destroy immediate instead of destroy. Parent.child count. Okay, child count is the number -1. I is greater than or equal to 0. I minus minus. Iterate backwards through the children. And Unity editor code, the usual pattern is use destroy immediate instead of destroy, and iterate backwards through the children. If you want a reusable helper, oh, cool. It gave us a static function we can add to our game object utils. So destroy all children, transform parent. So I believe we have a file called game object utils. So game object utils, and let's see, has sequence. Right. So that's not exactly what we want. We want with destroy all children. And our editor is not going to help us. And that's okay. Okay. Now let's go back to, that's good to know. So you have to go backwards on that one. Spawn menu, model behaviors, scripts, and destroy children. So now we can just say game object utils dot destroy all children. Hey, it saw that message at least, and this dot transform. I believe it wanted to transform, but it's not going to tell us that in the IDE. So let's go back there and destroy all children. Yeah, takes transform. Takes a transform. So now we should be able to refresh it. Game object utils does not contain a definition for destroy, because we spelled it wrong. So destroy all children. Go back to here. This is a challenge without help from the IDE. Destroy all children. There we go. While it's compiling. Next, what we're going to do is we want to, they're all overlapping, and we actually want to be able to space them in any direction. So we want to be able to go this way, row, column, or depth-wise. So let's go back. Oh, it's still building. So the main thing is, hey, what color we got? Let's go back to, okay, that works. And now if we call it build, and we got 6. Now let's build again. Build. We got 6. And that's why ChatGPT is great, because that could have been all day trying to figure out. Clear. Now we go back to here. All right. What we want, let's see if we can draw this in paint. Yeah. We want, we have a mono behavior that creates a row in either the X, Y, or Z direction. And the main thing about it is, for the alignment, so we're going to have alignment for the anchor. So alignment works like this. So I have a static method called interpolate bounds. So which takes a vector 3, and so all X, Y, and Z are each from 0 to 1. That's the range. And that just gives me a percentage along each dimension. So for X, for Y, and for Z, Z is like blue. It would be so 0, 1, 0, 1, 0, 1. And so for alignment, I have a method called anchor move. So I specify where I want to kind of grab the item by. So that would be 0, 0, 0, or I could say 1, 1, 1. And then I specify the point I want it to move to. And essentially, instead of moving it from the center to that point, so instead of it going to from here to here, the cube would be centered on it here. We want it to go from here, say if that's where we specified our anchor, to here, so that our corner is, so that the thing moves like this. And if we do that for each one, then when we calculate the spacing, we only have to worry about the previous one, not half of one, the first one, and then half of the other, and then worry about where the origin is and everything else. So that's the idea behind that. So what that means is when they specify an interpolation, so if they say I want to interpolate 1, 1, 1 in the positive X direction, the positive X, we need to take their X and set it to 0, because it doesn't matter if they're going in the positive X, it doesn't matter where they interpolate it along here. The result is they're going to be spaced along that, so that the X is irrelevant in that case. So that keeps it really simple if we do it that way. And so we're going to create a script, and we'll just call it, I'm going to call it row, but really it's like row, column, or anything else. So here we go. We need to add, it's going to call it row.cs, and using Unity Engine, do we need a list? No, maybe, but namespace. I don't think we do. DLN and public class row extends builder base. And so all we really want is the spacing. So public, this will be public float spacing equals, give it a sensible default 0.001 f. F at the end just means it's a float. And then what else do we want? We want the direction. I think we already have a direction enum. Let's look. So direction extensions, forward, back, left, right, up, down. Is that what we want? Yeah, that works. We can do it that way, or we can do it like X, Y, Z, and then positive or negative. I'd rather it be X, Y, or Z. That way it's very clear which way we're going. It really doesn't matter though. I don't want more than one direction enum. That's the thing. Alright, we'll use that one. That's fine. So we go to our row and we say we're going to let the user is us in this case, specify a direction equals, and the default for this should be, I would say direction dot right. I forget if that's capital. Nope. Yes, it's capital. And what do we want from here? Right. Public override void build. And I think eventually this will add like a layout function. So build will be like, okay, this instantiates things, and then layout would, it's already built. So some things you don't want to delete, you just use layout. Alright. So we want to start with the first one. How was it indexing the game objects? Let's look at that. Game object utils. The way that so object that parent dot get child. So get child. So we need to start somewhere, right? If we're going backwards, I'm not even going to give that option to go backwards. If they want to go backwards, we can just reverse the order in the list. I think that's the better way to go. So our direction enum, like we could say, okay, if we use that as just the direction, not reverse the children, that would work. Even better, we could reverse the list. No, we don't want to reverse the children list. I think this will work. So, we want var current equals transform dot get child at index 0, and then we got current, and then for int I equals 0, 1, I is less than transform dot, call it child count I plus And right. So public vector3 anchor equals, what does it say? New vector 3 0 0 0. So we're gonna have another function that says public private void and get start point. Adjust anchor. Yeah, we'll call it adjust anchor. And I'm trying to think. Yes. So we're going to switch on that enum. We're like switch direction. And we have a bunch of possibilities here. I just don't like using like an enum of 6 instead of having positive, negative, x, y, z. So we're going to create a new enum. It's just going to make it a lot easier to think about. So we're going to say public enum x, y, or z coordinate direction, Cartesian direction, axis, Cartesian axis. Could be x, y, or z. And then we can say public bool is negative. In fact, for our first iteration, we're not going to allow negative. That should make things a lot simpler. So we're going to switch. So direction is going to be Cartesian axis. Cartesian axis. Direction equals Cartesian axis dot x. So we got our anchor and our Cartesian axis. And for the adjustment of the anchor, if it's x, so in the case that it's x, we want anchor equals new vector 3, and we know the first one will be 0, and then the rest will be anchor dot y and then anchor dot z. So the same, the rest is the same. Just like with Unity, you have to reproduce the whole vector and then break, and in the case of y, our anchor is going to be new vector 3, and we want anchor dot x 0 and anchor dot z. And in the case of z, anchor equals new vector 3 anchor dot x anchor dot y and then 0. Very good. So, and then to make this a little easier to read, we will use the return value vector 3, and then var anchor onc. Why not? equals. Nah, I'm not gonna mess with that. That's just too. We don't have time for that. Ain't no one got time for that. Okay. Private, and then that's a void, just anchor. So we'll just do it procedurally. So we're gonna say just right here inside of build, adjust anchor, and from there, next we need the direction. We can call that each time. So get next distance, get distance, next distance, next move distance. We kind of want a cursor, so we start at the cursor and then we get the next move distance. Move cursor next, move next. How about that? We'll call it private void move next. And this will we'll also switch the direction, switch on direction, and so we switch on the direction. Oops. Tricky. It's probably the most stubborn thing a person could do is not set up the IDE to, check things for you and stuff. I'm just so tired of it. Okay. So we have move next, and then so you have a case X. We'll just break this out. Case Y. See, the IDE should be doing this for me, like fill it, like making stubs. In the case of Z, and break. Okay, we've got that. So in the case of X, we're going to want the current game object. So we'd say transform current, right? Yeah. Transform current. And do we need to know the next? I don't see why not. We can say get next position. So we can return a vector 3. That way this is a little more modular. Vector 3. Get next POS. Or get next distance. I'm trying to think. Get next. So if we know the current, get next distance. That would be what we want. So our next distance in the case of X, we want to get the bounds of current. So we'll go ahead and do that. So var bounds equals bounds dot get, we'll just do get world bounds of current. Yes. But in this case, bounds is going to be out parameter. So I believe we define an object as current, and bounds is out var bnds. We'll actually just call it bounds. It's easier to read. We'll confuse it with the namespace. There we go. So in the case of x, first we want the width, right? So so the current transform, that's the distance that we want. So we would first define a result variable. So var move amount equals new vector 3 0 0 0. In the case of x, move amount equals bounds dot size dot x. Right. So it'd be new vector 3 bounds dot size dot x. I believe that works. And then for y, move amount. This is really good brain exercise, having no help from the IDE. It's also a little bit, it's more time consuming, but I mean, by next year, it's not going to matter anyway. If you're doing manual coding, you're doing it because, you know, you're like one of those people who still use a hawkbill blade instead of a utility blade. Okay, size dot y. Oh, right. X 0 and 0. Bounds dot size. So the x would be 0. Bounds dot size dot y, and then 0. And then for z, I'll move amount new vector 3 0 0 bounds dot size dot z. From there, we're going to return move amount. Nice. Okay. Now, we would say var move amount equals get next distance and current. Okay. From there, we want I mean, let's call that previous. That's usually how you do it. So you call that previous. And we say var current equals transform dot get child at I. We got our move amount, and now we want to do an anchor move. So I defined that. So we got interpolate bounds. I think I have a full interpolate anchor move, but we might have to do it in 2 steps. So let's try to find that. Interpolate anchor move. I don't have it there. Oh, I know I defined a mono behavior that will do that. So let's go look in our mono behaviors. That way I don't have to rewrite that code. I called it EFG. Interpolate anchor move. So thing to position, that's just errors, and then handling errors. Interpolate bounds. If position equals null, interpolate anchor move failed to calculate position. Good. We got interpolate bounds. Interpolate anchor move. Our position or base. So in this case, it interpolated on both objects. I think that's what we want to do. Not exactly. At least we have move. It's called transform utils.move with anchor. That's all we need right there. Dot move with anchor. And the first one doesn't need to be moved at all, because this is just the spacing step, and it's like the align or adjustment step that moves all of them somewhere. That's going to position the first one and the last one, you know. Move with anchor, and then here, the thing that we're moving is not the current. Yes, current. And then the anchor point is position. Yes. So anchor point in this case is just anchor. And target point. Oh wait. Does move with anchor interpolate the anchor for me? Or do I need to first interpolate the anchor? Let's look at that. So we want, that's in transform utils. Like I said, I mean, it's probably not the best tutorial, but this is keeping me focused on my project. So, find anchor, move with anchor, right? So we got get transform, anchor point, move amount. Alright, so we still need to interpolate. And that means, so we got adjust anchor, get child 0. I almost want to use the cursor, because once we have the cursor set, then we just need to move that. So the start point, so var cursor equals, in fact, we want bounds dot interpolate world bounds. And I think I called it that when I made it a long time ago. Bounds, interpolate bounds. That's our signature. Bounds dot interpolate bounds. Go. We have an object. So object is prev float for t at x. That's going to be our anchor dot x. For t at y, going to be anchor dot y, and for t at z, anchor at z. There we go. And for all right, we got to interpolate bounds. All right, we got our start position like as a cursor. So you got the first item in the layout. Say we're going this way, we got our start position here, and now when we move it, we just move it to the next position and then anchor move the next item to there, wherever the anchor is set. And so that should give us, there should be one other argument in that one. So position and output coordinate space. I don't know how we didn't get those in there. Right? Out vector 3 position. So position, we would say out var, and that means our oh, that's where it was. That's all right though. And that's our cursor right there. We're defining it in place. That's kind of like why I like static functions without params. Out parameters. That means it guarantees that that value will be set. It's not like, usually you only get one return value. Out params allows you to give multiple return values. So I think it's just a better habit. And space. Output chord space, we're going to use, to make it simple, we're going to use world space. Output chord space equals space dot world. Guess I didn't have to retype that. That's all right. From there, current, I need some water. So that's our cursor. And then our anchor, for the first one we don't need an anchor. And then for current, we're going to need an anchor. So we're going to say var anchor equals this same thing. So we don't define it like that. We say like this. And this we need to name something else. Oh no, so that's the name of that is anchor. And then for the, what do we want to call this? POS target anchor. Current anchor? Let's call it target anchor. So we got the move amount, we got the target, we've got the interpolated position on the target, and so now we can do move with anchor. We're moving the current. The anchor point is actually at target anchor. How about we call it anchor on current? Anchor on current. Anchor point. Anchor on current. And then the target point is our interpolate bounds, get next distance, so move amount. Our target point is, so we would say, we got our cursor defined yet? Yeah. Cursor plus equals move amount. So our target point would be where we put our cursor. And then our out position, I don't think we need that. I think move with anchor already does that. Let's see if we can go to definition. We can't even go to definition. Okay, so we're gonna transform utils. Move with anchor, anchor point, target point. Does it move the item for me for each child dot position minus equals move amount? Oh, that's if we pin the children, but we're not pinning the children. Good. T dot position. Yes. Good. Cool. So we have a lot of code here. What are the chances? We should get a bunch of error messages. They should make the error messages in orange instead of red. You know, like grading, if you use red, it's supposed to be like scary or like negative or something. Line 11, we forgot a semicolon. Let's go to line 11. Good. These are the kind of things that IDE usually catches. So on line 24, output chord space does not exist in the current context. Line 24, because we use the equal sign. There we go. Next. X does not exist in the current context. Output chord space does not exist in the current context. So 35, I think we just fixed that. Oh, it's on another one too. Space.world. X, Y, and Z. Anchor dot. I guess it is a caps for a vector. Okay. That doesn't make sense to me at all. In fact, I'm pretty sure it's not true. X, Y, z. Vector 3 does not contain a definition for y, x, y, and z. I must have read that wrong. That's good. Okay. The name x, so that's line 52. Let's go to line 52. Case of, oh, right. Cartesian axis, I called it, dot x. Is it AN or ON? AN looks right. ON does not look right. So I think I got it right the first time. And to save us some typing, we'll just go Cartesian axis dot y and Cartesian axis dot z. Refresh. Oh. Refresh. Line 58. Control cannot fall out of switch from final case label. 58. Anchor. That means I need a break sign right there. Get world bounds does not have a parameter named bounds. Okay. So bounds. Oh wait. BNDS we called it. Let's see. Adjectives. So we need to find BNDS. Bounds. Position. No, that's interpolate bounds. So where's get world bounds? Find get world bounds. Bounds equals object at to world bounds center. So bounds center min max and size. Oh wait. At object center min max and size. Get world bounds object current, and then instead of bounds we want size is out var size, and we can get rid of these. There's like a trick to placing multiple cursors. I forget the shortcut key. Ooh. Let's just do this though. Get world bounds, current, out bar size, and then we want min is out max is out what center is out. That means we don't want those. So from here, X does not exist in the current context. 68, 71, and 74. 68. It's the same thing. Cartesian axis. So Cartesian axis dot X. Dot Y. Dot Z. Refresh. All right. Let's just see if that worked. I highly doubt that for the first time we do it, it's gonna work. So I'm just curious, and then I need a break. So row. So we're gonna add a row component, and we're gonna go the direction of x, spacing of 1, and anchor of 0, 0, 0. And we need to add that to our buildables. Buildable. There we go. And build. Did that work? Hold on. It doesn't look like it worked because the spacing is pretty awful. But it did go in the X direction. It's just our spacing's off. Now let's look if it goes in the Y direction. Y direction. And here we go. Build. Ha 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 ha. Ha ha ha. I think I want it to go downward though, because usually you're going to do columns. And then, let's see if we can go the Z direction. Z direction. Now we're going to go here and build. Let's see if we went the Z direction. We sure did. But that time it didn't do the spacing. So we get proper spacing except for in the Z direction. Oh, we're not even adding the spacing. So that's strange too. Because if we go in the X direction, right? And we build it. Build. It looks like it's going twice the width. So if our start is over, where are we starting with? So we're starting here. That is going really far. But only if it's X, right? And then if we go in the Y direction, do we get the same thing? Build. Oh, where are we at? Let's find them. Find. If we go in the Y direction, we don't get quite as much an error on spacing. And if we go in the Z direction, we don't get any error on the spacing. But already we have something decent as far as at least we see something. So I think that'll be next is why is it that size.x, y, and z, get world bounds, move mount. That would make sense for x, the move amount to be that. Maybe we're moving it multiple times. So let's look at that. Okay, y, z, x, 0, z, x, y, 0. We got that defined right, x, y, z. So t of x is anchor.x, anchor.y, and anchor.z. Position is out, or anchor on current. target point is current cursor plus move amount is get next distance. Previous. Let's make sure in get next distance we're not already moving the cursor. Nope. So move amount is get next distance of previous, and when we get the next distance, we are going by the size of the world size of the object, which is fine. So we don't have any weird scaling. X, Y, and Z. Those are proper. And are we defining the anchor correctly at first? So we got the spacing, the direction, and the anchor when we build. First we adjust the anchor, so that's good. And then for previous, we get to transform the get child. And we're going to interpolate the bounds on the previous. And then we do it again on the previous. Get next distance and then move with anchor. So this should be next current. That's what it is, I believe. I'm going to take a break though. That looks like what the problem is though. So we're going to stop streaming. And this is just keeping me focused. So I don't even think anyone's going to watch these tutorials, but this keeps me focused and keeps me from throwing stuff at the wall, because then